In this video, we'll be solving a quadratic equation by completing the square. Now what I'll do is I'll show the steps for solving the standard quadratic equation ax squared plus bx plus c equals 0. I'll show those steps on the left, and then we'll actually work a problem. We'll solve for x by completing the square. For this equation, 4x squared plus 6x plus 5 equals 0. And I'll show those steps on the right. So our first step is, if a is not equal to 1, divide both sides of the equation by a. So we can see that a, which is the lead coefficient, in this case is 4. So I need to divide both sides of my equation, which means I'll divide every term by 4. When I do that, these 4's cancel, and I have x squared. 6 divided by 4 is 3 halves, so plus 3 halves x plus 5 fourths equals 0. My next step is to rewrite the equation so that c is on one side of the equation by itself. Now c is the last term in this trinomial, usually the constant term. So what I want to do in our case is I want to move this 5 fourths to the right side. When I do that, it'll become negative 5 fourths. So I have x squared plus 3 halves x equals a negative 5 fourths. My next step is what I call the half it squared add it step. We want to multiply the coefficient of x by 1/2, square this result, and then add this number to both sides of the equation. So the coefficient of x in our case is 3 halves. I want to multiply that by 1/2. 1/2 times 3 halves is 3 fourths. Then I want to square that result. When you square a fraction, you square the numerator and then square the denominator. So 3 squared is 9, 4 squared is 16. And then you want to add this number to both sides of the equation. So let me copy my equation. X squared plus 3 halves x plus, and then I'm going to add my 9/16 to the left side. Then I'll copy negative 5 fourths and add 9/16 to the right side as well. So the half it squared added step, you want to grab the coefficient of x and half it, square it, and add it to both sides. My next step is to factor the resulting trinomial as a perfect square and combine like terms on the other side of the equation. So the whole reason for doing this half it squared added step is now on the left side I have a perfect square trinomial, and we know that we can factor those by square rooting the first term and writing that as my first term of my binomial. Take the sign of the middle term, so plus, and then square root this last term. So square root of 9 is 3, and square root of 16 is 4. Now that'll be this binomial squared is this trinomial. Also, I need to combine like terms on the other side. I'm going to need a common denominator. It looks like 16. So I'll multiply top and bottom of this fraction by 4. And I have a negative 20 over 16 and a positive 9 over 16, that'll give me negative 11 over 16. My next step is to solve this equation using the square root property. The square root property says if you have a quantity squared on one side of an equation and a number on the other side, you can square root both sides. So I'm going to do that. On the left, whenever you square root a square, those are inverse operations, so they're gone, and you just have x plus 3/4 equals, and then the square root property also says when you do that, when you square root both sides, you have to write plus or minus on this side, and we have the square root of negative 11 over 16. Now I'm solving for x, so I need to remove this 3/4 from the left side. I'll subtract 3/4 from both sides. These will cancel, and I have x is equal to, now this is a rational number, and this is irrational, so I can't combine those. I have to write them as separate terms of negative 3/4 plus or minus. And I'm also going to separate this single radical into two radicals. I have the square root of negative 11 in the numerator and square root of 16 in the denominator. Now the reason I separated them is because I can square root this 16 in the bottom. And then I also want to take care of this negative radicand up here. So I have x is equal to, we copy negative 3/4 plus or minus, and then whenever you have a negative under the radical, you can separate the radical into the square root of negative 1 times the square root of, in this case, 11, and then that square root of negative 1 is I. So I'm going to write this as I times the square root of 11. And that takes that negative out from under the radical. And then the square root of 16 in the denominator is 4. Now this is okay. Usually you'll see this written in a plus bi form. So let me do that. This is negative 3/4 plus or minus, and then a plus bi form means I'm going to have my I out in the back. So I have the square root of 11 over 4, and then my I is in the behind the numerical coefficient.